Okay, good morning. I've recently posted something about being very frustrated with people's understanding of DNA and wishing that there was more of a conversation with correct information. And a lot of you started asking me questions and kind of challenged me to create something to help people understand. So this is what I've come up with. I'm going to try to do my best to explain everything. I was originally a biology major with a focus on genetics, so I'm not an expert. I did not graduate with that, but it's a huge interest of mine, and I hope that sharing what I know with you will help you. And of course, I'm open to corrections, questions, or anything like that. So I guess with that, I will get started. So the first thing that I wanted to talk about was dominant versus recessive. There seems to be a misunderstanding on this sometimes, at least with a few people I talk to. So dominant is something that only requires one copy. A dominant gene would be something like fawn, which is AY, brindle, KB, sometimes KBR. Merle is also a dominant gene. So these are things that if your dog gets one copy, it will show these visually. Recessive means that they must get two copies, one from mom, one from dad. And we'll go further into this, but that is just the very basics of dominant versus recessive so that we can talk about how genes combine to create these different looks. So that brings us to phenotype versus genotype. So phenotype is how you look. So for me, that's brown hair, brown eyes, pale skin, being female, anything like that. That's things that you see visually. So for dogs, that could be fluffy, that could be pied, that can be any of those things. Genotype is what is in your DNA. So for a dog, that could be carrying fluffy, carrying cream, things that you do not see visually. Now, genotype can express if a dog has a dominant gene or two copies of a recessive gene, that can be expressed physically. And so then genotype and phenotype match. So it's basically just what's in your DNA versus what you actually see. And that will bring us to the different locuses or loci. So these are what control each trait, and we'll go through them all. But as you can see, I listed out the locuses that we generally focus on in French Bulldog DNA. Obviously, this is completely focused on French Bulldogs. I don't breed anything else. I have no knowledge of anything else. So if this doesn't apply to your breed, I'm sorry, you'll have to ask somebody else. So the locus is, as I said, just each control point. It contributes to a different genetic type and therefore can contribute to different phenotypes, how they look. So how do you predict what you're going to get out of a breeding? And this is where we come to Punnett squares. So this is a Punnett square. It's just one big square divided into four smaller ones. And you're going to look at it one gene at a time, one locus at a time. So the way you can do this is you can have mom on top or on the side, doesn't matter, and then dad on the other side. So for this example, we're just going to start with blue. Blue is marked by D. So blue is little d. And one thing to understand is that in genetics, most of the time, a lowercase letter represents the dog carrying or having that trait. And an uppercase letter represents basically the negative, that the dog does not carry or have that trait. So a blue dog, which is a recessive gene, would take two copies of little d. to be a carrier, they would have a big D, little d. So they have one copy of that recessive gene. So it does not show up in their phenotype. They will not look blue. To have no blue, they would be big D, and that is completely negative for blue. So for this example, I'm going to breed 2 blue carriers to show you how they can, what they can have. So mom is a carrier, big D, little d. Dad is a carrier, big D, little d. And all you do is you do this by the row and column and bring them in. So big D, big D. And then I'm going to bring this big D across and bring the little d down. Big D, little d. Same thing here. Big D, little d. Little d, little d. So these 2 parents, blue carriers, can have completely no blue. They can have blue that actually look blue. And they can have carriers. Now, obviously, they can make carriers twice. So you have 25%, one of the 4 squares, 25% chance of having no blue. And this is per puppy, not per litter. So if they have 4 puppies, do not expect 1 blue, 1 non-blue, and 2 carriers. This is per puppy genetic lottery. They will have a 25% chance of having 0 blue. They will have a 25% chance of being blue. And they will have a 50% chance of being a carrier. And that is the basics of how our Punnett squares work and how you can begin to predict what 2 dogs can have and create. So from there, we're going to talk about the different loci. But to get into that, we're going to talk about how genes work. So I'm sure you've all seen the DNA double helix. It looks like a ladder that has been twisted. And one side is from dad, one side is from mom. They each give 1 gene to each locus. And those basically create your pairs of genes that turn into your chromosomes that make up your DNA and create who you are or who your dog is. So if you look at DNA stretched out, you will see that there's basically sections of DNA that are the locuses. These are the things that affect each category that we're looking at. So, you know, it might be this is A, and this is B, and this is C, which I totally forgot to put on here, but I will add that, and this is D. So, yeah, this is basically how your dog's genes might look. There's longer and shorter sections. There can be junk sections that don't contribute to anything, and there's a lot of sections we don't understand. So there you go. I'm going to add that cocoa locus. I'm sure most of you were noticing that that didn't exist there. So now that we understand that mom contributes one of her 2 genes and dad contributes one of his 2 genes, but it's totally random which one they contribute, we can move on and go locus by locus and talk about how they create the different things that we see. So I'm going to go ahead and erase some of this and start talking about each one. So the first one is the A locus. And for A locus, we have a few options. We have little a, which is basically solid colored. No tan points, no fawn. We have AT, which is tan points. And we have AY, which is fawn. And these are basically in order of how dominant they are. So if your dog has an A that is the most recessive, if your dog has tan points. Those are more dominant than A, but less dominant than fawn. So if your dog has fawn, that is the most dominant. That is a dominant gene and will show almost every time. And I'll explain the times that it does not show as fawn when we get down to how things interact. But to begin with the locust, this is what you can have. Then on our B locust, we only have two options. This is known as rojo. So you can have big B, which is no rojo, or you can have little b, which is rojo. Now, this is recessive. So this takes two copies to create a rojo, and big B, little b would be a carrier. Same thing with cocoa. If you have a big C, little o, that's a negative. And if you have a little co, that is cocoa. And again, recessive. So two copies to visually phenotype be a cocoa. Then D locus, as we already talked about, you can have big D, negative, little d, blue. And the reason that this is a D is because it stands for dilute. It dilutes black down to the gray that we call blue. Then our E locus gets a little more interesting. So you can have EM, which is mask. So this is the black mask on a fawn, or sometimes it looks like a gray kind of mask on a blue. So this is a mask on the face. You can have big E, which is maskless. And that means that there will be no mask on the face. These are basically most to least dominant. So little e, totally recessive. This is cream. This requires two copies to show up as a phenotype. So you can be a cream as little e. You can be a cream carrier as either one of these with a little e. And then you could be totally negative cream with either one of these or a mix. Now, if you are EME, you will still have mask. If you are EMEM, you will have mask. If you are big E, you are no cream and maskless. So this is the most dominant. It will overpower our maskless, and it will both of these will overpower cream unless you have two. Again, dominant to recessive, needing one versus needing two. And again, needing two, but it takes two of these to overpower any of these. Then we have K locus, and K can be KY or KB or KBR. Now these two are basically combined. We don't really have a test, so we are just going to refer to it as brindle and non-brindle. So there can be some different expressions of the brindle gene, but we don't have a way to differentiate those yet. So KY, no brindle, KB, brindle. Now, brindle is dominant. It only takes one copy, but it does not always express in the phenotype unless there's some specific interactions, which we will get to again in a second. Now, that's basically all of our colors, although brindle is a pattern and tan points are a pattern. But I'm gonna erase these and we're gonna go into patterns and coats and how those work. So next up we have our S locus. This is pied, and that is also recessive, but in a funny way. So big S, negative for pied. Big S, carrier. Little s, we have pied. Now, what's weird is when you have big S, little s, you can get white spotting, maybe a white chest or a white chin or a white spot on the back of the neck. But the really funny one is Irish pied. And that is when you have, you know, your dog, I'm just gonna butcher this. And they are not pied, they are a carrier. But you will see color on their head, their ears, but they might have like a white collar, they'll have white legs and a white stomach. And they will basically look like they're wearing a blanket. So this can sometimes be called blanket pied as well as Irish pied. And we do not know why sometimes that one copy of pied decides to express this way. There has to be more genes interacting that we have not found yet. But if you see somebody say that they have an Irish pied, this is what they mean. It is a pied carrier that has more white than it should. And on that note, not every dog with a white spot carries pied. That's not a definitive way to tell. White spotting is fairly normal, even without pied, just in much smaller amounts. Then we get to Merle, and Merle is one of those super crazy genes that really makes things misunderstood and can make things really difficult if you don't understand. So, big M, no Merle. Little m, Merle. So if you have two big M's, no Merle. If you have big M, little m, you have a Merle. That is a dominant gene. Now if you have little m, you're in danger. You don't want double Merles, and I can explain further on this, but let's talk about the kinds of Merles first. So, Merle genes have a length. So, let's say that on the other end of this D, we have a Merle dog. And the Merle gene could be very long, or it could be very short. So we'll start off with, the shortest one. The shortest one is called cryptic Merle, and that is MC. And the length of the gene is called the SINE. It stands for something. I don't have it memorized. Doesn't really matter. All you have to know is the SINE is the length of your Merle gene, and this affects how much the Merle expresses on your dog. Cryptic Merle. They're not going to look Merle. You're not going to see any signs of it. They will not have different colored eyes. They will not have spots on their fur. They will not have pigment deletion. So that's why this is called cryptic. Now, you can have cryptic plus, which is just a tiny bit longer. And that, again, will likely not show as Merle. It's basically invisible. After that, we have atypical, which is MA. And that would be just a little bit longer than this MC plus. So we're going from shortest to longest here. And this atypical, you might see some signs. You might see a tiny little bit of spotting in the coat. It's not going to be obvious. Maybe they'll have a speck in an eye that's a slightly different color, a brown eye with a blue spot or a green spot, something like that. But you're really probably going to question if they're actually a Merle. Then we can have MA plus. Again, just slightly longer than that MA. And again, you're probably going to see very few signs that it's actually a Merle. After this, we have your standard Merle, which is just M. And so that, again, just a little bit longer than these other ones. And this is where you're going to see a dog that just looks Merle. They have darker and lighter colored patches and kind of, look spotted, just standard Merle. After this comes the MH. And this is what a lot of us really like. This is your longest Merle gene. And each of these can have a range of lengths. I could look this up, I could write it down and insert it in here in a little bit. I do not have those memorized, but MH can be at the shorter end, it can be our tweed merles where they kind of look like 3 colors or 4 colors. It's all, you know, a chocolate tweed would have light brown, medium brown, dark brown patches, and that can look really neat. And then we have Harlequin, which is what the H stands for, and that is our longest merle, and that causes white within the spots of merle. It is complete color deletion, pigment deletion inside of our merle pattern, and that is the longest one. So when we are talking about breeding a merle, this is why it's important to test. You need to know not only is your dog a merle, because they may not look it, but you need to know what the length of their merle gene is, especially if you want to do a merle to merle breeding. And this is something that I really don't recommend, but some more experienced breeders do this. And basically what it is these short ones, you can double up on them fairly safely. So you can breed a cryptic merle to an atypical merle, or an MC plus to an atypical. Once you start getting up to this MA plus, the atypical plus, you start to get into danger. And the whole reason for that is that pigment deletion. The longer the gene, the more deletion it causes until you're actually getting white in the merle. And I'm sorry, my dog's scratching. You can probably hear that. So once you get this pigment deletion around the eyes and the ears can cause deletion within the eardrum and the eyes, which can lead, sorry, very itchy, which can lead to deafness, blindness, and problems like that. So definitely highly recommend looking into sign length of merle very deeply and understanding what merle number you have in your dogs before you ever consider breeding merle to merle. It's been done. Some people have gotten lucky, but a lot of people do not, and you're never going to see those ones. They're never going to tell you, I tried merle to merle. I had a litter of 7 and 4 were, you know, blind, deaf, whatever. Like, they're not going to tell you that. They're only going to show you the success story and make you think you can do it, or make you think that it's something super special and not dangerous, but it is. So we'll move on from that and we'll talk about Fluffy. Fluffy is recessive and it is marked by an L, big L, negative, little l, Fluffy, carrier. Well, that means they have the Fluffy gene. So little l, Fluffy gene. Again, recessive, so LL is a carrier. Now, when you're reading DNA on Fluffy, you're going to see a number. So you might see L1, or the other most common one is L4. And this really means very little to us. It's different Fluffy genes, and I believe they are L1 up to L5, 1 and 4 being the most common in Frenchies. I have heard that it is a length description, that an L1 will have shorter fur than an L4. So if you have an L1, L4, they might have kind of a medium coat, but if you have an L4, they'll have a longer coat. I am not 100% sure that's true, but that is how it's been described to me. So I will have to look more into that and find out if that is actually scientifically proven. So again, Fluffy, pretty easy. Recessive gene, takes 2. Otherwise, they're a carrier. Curl, you can either have no curl, which in this case is delineated by an N, just for none or no. And then you can have C1 and C2. And these are both curls. I have heard that C1 is tighter curl, I believe, and C2 is less. As far as I can tell, there's probably something more that goes into that. I've seen some very curly dogs, some less curly dogs. You can double up on these, so you could have C1, 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 C2, 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 and get a very, very curly dog. Again, this is not recessive. This is a dominant gene. So if you have a curly gene, your dog will have a curly coat. You may not see it if they're not fluffy, but if they're fluffy, you will see the curl. Then we have furnish. So you can have, usually the way it's expressed is F-N-I-C. F is furnishing, and IC is incorrect coat, I believe. So our smooth-haired dogs are considered incorrect coat. Sometimes you'll just see it as an N, as in no furnishing. That's just kind of up to the company. A lot of them have different ways of saying or reading their DNA tests. So N and IC are generally the same thing. They're smooth coat. Furnishing is a dominant gene. You only need one copy. Now, furnishing with fluffy, with a full fluffy, so 2 copies of fluffy, has become known as the flutal or teddy bear. And then there's the flutal creators or just wire hairs, which are a short hair or a fluffy carrier with the furnishing gene. So they tend to look like just kind of wire haired. They don't have the full flutal puffy coat. Now the furnishing gene can be very, very misunderstood. People call it wire hair, people call it furnishing, people call it flutal, people call it teddy bear. All it is if you look at a lot of like the terrier breeds and dogs that normally have the wire hair, you will see that they grow longer eyebrows, kind of a mustache, maybe a little beard. That is the furnishing gene. It creates longer, slightly more wiry hair. It does not necessarily mean it's wiry in texture. A lot of these dogs feel soft to the touch, but their coats appear wiry. The hair is a little thicker. It will stand. They may have a little bit of curl to it, even without the curl gene. So yeah, we can talk about the interaction of the furnishing gene with fluffy and non-fluffy when we get down to interactions here. And then husky and coy. This is a big one because it's still fairly new. So the husky gene, the panda husky gene, because now they've also added EA, which is the Siberian husky gene. Panda husky gene came from panda pugs, if you've ever seen them. So that is actually the KIT gene, but we're just gonna call it kit or husky, whatever. And this gene is dominant. It only requires 1 copy. Now, what a lot of people miss is you cannot carry this gene. And that is because it is actually double lethal. So if a mom and dad are both husky or coy, which coy is only KIT. So this is husky. KIT plus Merle is a coy. That's all it is. So if you have an understanding of this, then you understand that a coy is just a husky that's also Merle. Now, if we take a mom and a dad that are both husky, coy, whatever, but we're just gonna focus on that KIT gene. So parent 1 has KIT, and then obviously negative, because you cannot be a carrier. KIT, and then negative. Now, when we fill out our Punnett square, we get 2 times KIT. Then we get KITN, KITN, and then totally negative. So what you're gonna get when you breed this is around 25% of your puppies are gonna be regular, no panda pattern, no coy. 50% of your puppies are going to be that husky or coy. This 25%, they're going to die in utero, be reabsorbed, be delivered stillborn. There has never been 2 copies of Kit Gene dog born alive. It has never happened. It will never happen. Again, this is due to pigment deletion, which I was talking about with Merle and how that can be dangerous. This deletes so much pigment that they cannot be born alive. They can't survive. So do not breed a husky to a coy, a husky to a husky, because all you're doing to yourself is reducing your litter size by statistically 25%. Now, if we look at breeding a husky to a non-husky, what do we get? We're going to get a husky, a non, and a non. So now you have 50% husky coy, 50% regular Merle, tan point, whatever the DNA makes up for that other half, with no panda pattern. So this time you still have 50% husky, but you didn't reduce your litter by 25%. So anybody that says I did a husky to a coy, I did a husky to a husky, I have a double husky or double coy, they're not doing things in an ethical or healthy way, and they probably don't know what they're talking about. Not going to call out any names, but if you've seen these people, just beware. They either don't know what they're doing or they're breeding dangerously, and they will never have a double husky or a double coy. Next, big rope. This is just a dominant gene. There's really no way to test for it. You will see it visually. It is dominant, so if you breed a big rope to a big rope, you will likely get, we'll just call it little b, even though that's Rojo. Maybe we'll call it BR and little BR. So here's your big rope genes, here's your not big rope genes. So you're gonna get puppies that are not big rope, puppies that are single copy of big rope, and puppies that are not big rope at all. And this is all fine as far as we know. This is questionable, and that's only because the big rope comes from the Shar-Pei that have the very fleshy face and a lot of wrinkles are what's known as the meat mouth Shar-Pei, and there's the bone mouth, which does not have all of that. The meat mouth, when they double up on those genes, they tend to get what is known as spayed. S-P-A-I-D. This is Shar-Pei autoinflammatory disease. And this is an autoimmune disease caused by the excess hyaluronic acid. And when there is too much, they get fevers, swelling, all kinds of issues, and it's autoimmune, so there's no cure. And yeah, it's a very horrible life. Breeders are starting to get rid of the meat mouth Shar-Peis. Actually, so this is wrong. I should have circled this, the big rope. But either way, I think you understand what I'm saying. A double big rope in the Shar-Peis is associated with this disease. We do not know if that can transfer to Frenchies. This disease usually does not show up for a few years. So people who say I had, you know, a big rope to big rope and all of the puppies were fine, they're in homes, I've gotten updates and they're still healthy, we don't know if they're going to be in 3 years. So that's just something to watch, something to pay attention to until we know if this is a disease that can affect Frenchies. Now that we've gone over that, what else do we have left? Interactions. So this is where we get to the fun. I'm actually just going to erase this whole Punnett square. So let's start at A. So I talked about how fawn, A-Y, is the most dominant on the A locus, but it can be covered by other things. And those things are K. So if we have a dog that is AY, but also KB, you now have a brindle dog. Brindle plus fawn makes the dog entirely brindle, which is that tiger stripe pattern. You know, you'll see those black stripes in the fur. Now, if you don't have brindle, your dog's back to fawn. But if you have cream, again, recessive, so EE, so a full double cream. Cream is the white paint of the dog world. It just covers everything. Everything here, if you put cream over it, you are cream. That is your phenotype, even if your genotype is different. So even though the genotype of this dog would have fawn, it is now visually cream. Now, we talked about how below fawn, we have tan points. So a dog with tan points will have visual tan points until you add that brindle. And at this point, they became a trindle. Now, what's fun about brindle and tan points is now the brindle, that black striping, only shows up on the tan points. The cheeks, the eyebrows, the feet. You're gonna see black striping that may almost hide the tan points. You may not even be able to tell the dog has tan points. So that's what we call a trindle, tan point brindle. And that's a really neat way that these locuses interact. So the tan points don't get wiped out, but they do get changed. So then if you have anything AY, AYA, fawn, AYAT, fawn, AY, fawn. So if you don't have the brindle and you don't have double cream, this is what you have. You will always have a fawn. Now, with the AT, we have no fawn, we have ATA. A is solid, no tan points. AT is tan points. This is more dominant, so you will have tan points. Now, if you have AT, you're going to get those really defined, bright tan points. Now, the color of the tan can be affected by things like intensity, the rest of the coat color, whether the dog is blue, lilac, whatever. As long as you don't have double cream and no fawn and no brindle, you will have the really bright, defined tan points. These will likely be less so. Now, if you have a dog that is AA, they will be solid. Now, if they are AA and they have brindle, will not show. You don't have fawn, you don't have tan points, the brindle does not show up. So even though it is genotypically brindle, it is phenotypically not. You will not see brindle. So the AA will be the solid of whatever color they are made up of by the rest of their DNA. And if they have the two cream, again, e, little e, that will paint over this, they will be cream. So to the B locus, we've talked about that. You can have big B, which means no rojo, big B, carrier, little b, they will be visually rojo if they don't mix with anything else. Now, here's where we get really fun. So we're gonna go through just what the recessive genes can make. So we have DD, blue, CO, cocoa. We have little b, rojo. It's annoying to read that twice. Now we have our little e, cream. So what happens when we start combining all these recessive genes? We have a dog that has a bunch of these. So if they don't have these, we have blue. When you have DD plus COCO, but no BB and no EE, now you have lilac. And then if you have blue plus rojo, you have what we call Isabella. Now, if you put the EE with any of these white paint, they're cream. This is what their genes are underneath, but they will appear cream. Now, if we take CO, CO, and BB, this is what we call new shade rojo. Now what happens when we put all of these together? So we have DD, CO, CO, BB. This is new shade Isabella. So essentially what happens is when you add cocoa to something, it becomes a new shade of what that color is. So lilac should technically be new shade blue. And that is an easier way to remember this, is that cocoa added to anything makes it the new shade of whatever color. Cream, again, white paint covers everything. So if we put an EE on any of these, you've got a cream dog. Then we're going to get to the S locus. So you can have any of these colors. And if you have big S, little s, you might have some white spotting on these dogs. Maybe a white chest, maybe a white chin, maybe a little bit of white in the middle of the face. Not a lot usually. They could be the Irish pied or blanket pied, but that's pretty rare. So chances are they're just going to have a little bit of white. Now, if we have these dogs and they're full pied, you're going to get those spots. So you have, oh yeah. We're going to do our crappy dog. You're going to have full-blown spots with a lot of white base with spots of whatever color they are on top of that. And now you have a pied new shade Isabella or a pied new shade rojo. Now, of course, if you add your tan points to any of these, now you have a pied lilac and tan or a pied Isabella and tan. So that's where the pied can come in. Now, if we add a fawn, all of a sudden you have a lilac fawn. And that means that anywhere that you would normally see that kind of pointing on the face, on the eyebrows, on the cheeks, on the legs, you will see evidence of the underlying color, but the main color of the dog will be fawn. And then again, if we have like AA, they will be solid. They will be solid lilac, solid Isabella. So there will be no tan points, there will be no fawn. Now if we make it a TA, they will be lilac and tan, but again, they're gonna have the less defined tan points. The tan points will not be as bright, they will not have the defined margins and lines, and you know, they're still tan pointed. They're just not as strong. Now if we make it AT, now you have those really strong tan points. So both of those could be lilac and tan, Isabella and tan, whatever and tan, but that will have the very strong tan points. And again, put EE, put those 2 copies of cream over it, white paint. All this is underneath. This is their genotype, but it is no longer their phenotype. They are cream. From there, again, fawn can make any of these colors plus fawn. Now, if you take that mask, so we have that EM gene. So this could be EME or EM little e. So this could be mask plus maskless, or mask plus cream. Now you're gonna get a more defined color on the face that is different from the body. So especially like around the muzzle, this is where you see black masked fawns. They have a very fawn face, fawn body, black muzzle. That is where the mask will come in. So if you have a lilac fawn with mask, you're gonna see that lilac very defined on the face. Blue fawn, Isabella fawn, you're going to see that color more because of the mask. If we take the mask away, and we have big E, little e, or big E, big E. Big E is maskless, E is cream. Cream is recessive, so this isn't gonna show up. Then you're gonna have a very hidden amount of whatever color in the fawn or in the coat. Whatever color they are, you are not gonna see that very defined difference in color on the face. So that goes over E locus. We did brindle plus tan points plus fawn. We did pied. Okay. We talked about Merle and all of the dangers of Merle, double Merles, and sign length. So there's not much to go over here. You can have every color, add that little m. Now you have a lilac Merle, a blue Merle, a fawn Merle, whatever color the dog is, plus the Merle patterning. Now, again, you add cream, little e, white paint. You're never gonna know that dog's a Merle. You will not see it. Now we'll talk about Fluffy. So we have usually L1, L4, something like that. This is recessive. Again, you have big L, little l, carrier. This will be a full Fluffy. You have big L, no Fluffy. That's it. So that makes it really easy if you want to create Fluffies. If you have a carrier and take it to a carrier, make your Punnett square, big L, little l, big L, little l. Now you're gonna have 25% non-fluffies. Big L, little l, big L, little l. You're gonna have that 50% fluffy carrier, little l, little l. And you should have around 25% fluffies. And again, statistically, this is per puppy, not per litter. So we like to say, you know, if you had 4 puppies, this is what you should get. It does not work like that. You should get 50% male, 50% female, 50% fluffy carrier, 25% fluffies. You may get no carriers, no fluffies, and all fluffies or all carriers. It's just a genetic lottery. This is, in general, how you can plan for what you want, though. This is a prediction. It's a statistic. And that is all there is to Fluffy, is your dog can be fluffy, carrier, not fluffy. Now, when you add Fluffy plus furnish, so we have L1, L4, plus an F. Now you have the teddy bear, the floodle, whatever you want to call it. People like making up names. I don't understand all the different names, why we're arguing about what they should be, but this is a Fluffy with furnishing. And now you have a dog that looks like a floodle. It will have the longer eyebrows, longer mustache hair, longer beard hair, all on a Fluffy. The hair might be a little more wiry, a little more curlier, a little more of like a terrier or poodle type coat. Then if you have big L, little l furnishing, you're gonna see the wire hair, but on a short coat, they're basically gonna look kind of spiky. You'll see wiry hairs on a short coated dog. They can make the floodles if you take them to a Fluffy or a Fluffy carrier and you get 2 copies of Fluffy plus furnishing, but they also may not. We talked about husky coy and the dangers there. Now the interactions with this, you are not going to see any interactions. You can have a fawn husky, you can have a fawn coy, you can have a tan pointed husky or coy, you can have every color husky or coy. Again, the only way you're not gonna really see it is if you have the cream, the EE. So, the EE, white paint, you might still kind of see the pattern and you'll know if it's a husky or a coy, but from 10 feet away, it's just gonna look like a cream dog. We talked about big rope. That again has nothing to do with color or coat. You can have a big rope short coat, big rope fluffy, big rope coy, big rope flutal, whatever you want. You can have a big rope that's Merle. So that's mostly just from a health perspective. I wanted to go over that. Now, the last thing I want to talk about that I didn't put on here is pink, because it's so new. And this is one that is kind of odd because it sometimes goes by Cal, and sometimes it goes by a capital A. And this is the one time that we really see a gene shown as a positive, as a carrier, or having the gene with a capital letter. Obviously, we talked about the A locus, and you have a Y, A T, and those are all lowercase. So this is not the A locus. A capital A, these are pink, which is just a fancy name for albinism. So what's really crazy about pink is that one, it's shown with a capital letter as a positive, and two is there's two different kinds of albinism, and this is where people get super confused. They'll tell you, so we got pink from Pekingese and pug, and this is where our Frenchies got pink from. Now, people will argue all day about which is better. Now, I don't know how much dog history you know. These are the same. These are Asian breeds. They came from the same ancestors. Their pink gene is the same gene. So arguing about that makes zero sense. What we do know about pink, though, is a lot of times you will see a full albino dog, a full pink dog, and they'll say it's a Merle, or it's a husky, or it's a coy. And you can see that pattern in their coat. So, you know, you have your dog, and you can see that there's Merle in that pink. A true albino, you shouldn't be able to see that, right? They should have, when you think albino, they should have pink eyes, white coat. They should have pink skin and nose. They should literally have no pigment to them. So why do we see these dogs that typically have blue eyes? And you can see the pattern. And maybe you've seen the caramel pinks. They're not white. So why is this not following our albino pattern? It has nothing to do with which breed it came from. It has to do with a chemical precursor to melanin. Melanin is our pigment. Tyrosine. So tyrosine is the precursor to creating pigment in skin, coats, eyes for these dogs. And so in albinism, you can have tyrosine positive or negative. Negative, no tyrosine, no precursor to pigment. This will be red eyes, pink skin, and white coat. You know, this is translucent, obvious albino. Now, tyrosine positive, you have that precursor. You get blue eyes. You still have light skin. You can have a tinge of color to the coat. This is where you get people saying, I've got a caramel, or you can see a pattern. And it's all because the tyrosine is sitting there where it would create melanin pigment if it could. It can't, but because you have this sitting there, you can see where it is, where that color would be. And it does cause things like the blue eyes. Now, don't get all excited and think that because they have the precursor to pigment that they are any healthier than these ones. They are not. They have the same problems. So I'm not telling you not to breed pinks. But if you are going to breed pinks, be aware. There is a higher risk of eye issues, hearing issues, skin cancer, things like that. Be careful. Do not take them out in the sun. If you're going to be outside for a long time, put them in clothes. There are dog sunscreens. Protect their eyes from the sun. Give them plenty of shade. And be very careful that they don't get sunburned. They will get skin cancer because they cannot get a tan. They cannot adapt to sunlight. So these are two different types of albinism, same problems. Now that we've gone through everything, I'm gonna grab a drink and then I'm gonna come back and we're gonna go through reading DNA and we're gonna see if you can figure out what different combinations are before I tell you. I hope everything's in frame. I'm filming this on my phone and I can't do it with the screen facing me because of, it would reverse all the writing. So we're gonna get started again with reading DNA. I'm just gonna give you some of my dogs. So my dog Ripley is I'm not even gonna tell you, I'm gonna let you figure it out. She is A-T. We'll call it Big B. Really, she's N. C-O, little. D. I believe she's E-M, little e. She is Big L. She is KY. She is little s. She is Big M's, which is, again, Merle. She is, we said Big L. So that is that. So I'm gonna ask you to pause your video here, look at this, and go locus by locus, and try to figure out what she is. And in just a second, I'm gonna go through it here. Okay, so hopefully you paused, you tried to figure this out because this is the practice that will help you really internalize reading DNA to the point where you don't need Punnett squares. You can look at two dogs' DNA and figure out what they'll make in 30 seconds. So, Ripley, double tan points. She's got defined tan points. Big B, no Rojo. 2 copies of Coco. So, genotype, she is Coco. 2 copies of Blue. So, what did we say when we put double Coco, double Blue together? Lilac. EM, mask. Little e, cream. That's recessive, so she is not covered in cream, she carries it. Big L, no fluffy, she is short-haired. KY, no brindle, so she is not a trindle. And she has no fawn, so she is not a brindle. She is just basically negative. Little s, she is pied. Big M, no Merle. So what does this give us? This gives us a mask, lilac and tan, pied, carrying cream. Hey, Ripley, come here. Come here, Rips. Come here. Oh, I know, what am I doing? So here's Ripley. She's just a pet, but she was my first Frenchie. And she is just my little lilac and tan pied girl. We love a good pie. Oh. All right, we're gonna do Ripley's sister next, because now that you've seen this, you should be able to figure out what she is pretty easily. So, there is only one change to her sister, who is Rune. That's it. So again, what would this little M change about the whole thing? If you want to pause, go ahead and pause now, and then I'm going to get started here on exactly what we changed. Okay, hopefully you figured this out. Everything's still the same. So we still have lilac and tan, carrying cream, masked, no fluffy, no brindle, pied. All we did was add Merle. So we have a lilac and tan, masked Merle, pied, carrying cream. Come here, Vin. Oh. Now, Rune is just a pet. Again, she's my second Frenchie. She had glaucoma. She has one eye. But she is a pied Merle, lilac pied Merle. And I did have her pied her Merle SINE tested. She is a harlequin. So you can see she has white hairs in her Merle patches because of the extra pigment deletion. Now, one thing you may notice, Rune's hood, which is the coloring on her head, has a white stripe through the middle. She is what's known as a double hooded pied. So she has a split hood. Now, what's good about Rune is you can see the color reaches her eyes, or at least where her eyes should have been. So this, and it's on her ears. So this is good for not having an extreme pied. An extreme pied with lots of white on the head and ears can also be blind and deaf, just like a double Merle. So this is what's known as a double pied, or a double hooded pied. Come here, Ripples. If I pick Ripley back up, you will see that her white stripe does not break her hood. So she is just a hooded pied. And again, she has color on her, around her eyes and around her ears. So we are not at risk of blindness, deafness, or any deficits in those areas caused by pigment deletion. I know, baby. You're a good girl. Okay. Let's move on. I am going to, I'll do you, just wait. I'm going to move on to my third Frenchie, the first Frenchie that I ever got for breeding. This is River. She is A-T. Big B, big B. N. Remember, N is also the same as not having it. It's negative. N, little C-O. She is little d, little d. She is E-M, little e. She is big L, K-Y, K-Y. Big M, and big S, big S. So go ahead and pause here and come back when you think you have what River is. Okay. Hopefully you had a little easier time now that we've gone through this a few times. River, ETAT, 10 points. Big B, no Rojo. Only one copy of Coco. She is a carrier. 2 copies of Dilute. She is blue. EM, that is our mask. Little E, cream carrier. Big L, no fluffy. KY, no brindle. Big M, no Merle. Big S, no pied. So she is a blue and tan carrying cocoa and cream. That's it. River, come here. Come here. So this is River. She is my blue and tan carrying cocoa and cream. She has a copy of Mask. So as you can see, what would have been a black mask, she's only 3, she's not old, but what would have been a black mask here is diluted to this very light gray by her blue coloration. You can see her tan points, she's AT, so they are very defined. And then you can see she has a little white spot on her chest despite having no pied. That's just that random white spotting. It happens. Yeah. Good girl. Thank you. Okay. Now, I only have one more dog running around up here. The other ones are downstairs right now, but we're gonna go ahead and do Lydia. She is AT. I think you can tell that I like my tan points. She is big B, little b, big CO, little co, big D, little d. I can't remember. I think she's big E, little e. It doesn't really matter. We're just gonna go with that because we haven't done this one yet. She is L1, L4. She is KY, KY. She is big S, little s. She is big M, big M. She has C1. Now, go ahead, take your time and figure out what you think Lydia is, and then unpause the video when you're ready, and I'm going to go through her. Okay, hopefully you did your homework here. Again, this should be easy. AT. No fawn, no solid, she's tan pointed. Now, this, she carries Rojo. Rojo, carrier. Coco, carrier. We have big CO, little co, carrier. Blue, big D, little d, carrier. Big E, little e, carrier. KY, no brindle. L1, L4. She is a full fluffy. Big S, little s. Pied, carrier. Big M, big M. No Merle. C1, curly. So this is something that gets a lot of people here. If a dog is not a color, if a dog is not fawn, it's not Rojo, cocoa, blue, cream, not brindle, what is it? This is black. Black is our base dog. If you do not double up on a recessive color, if you do not add fawn or brindle, you have black. If she was AA, she would be solid black. But she is black with tan points. Now, what's really cool about her is I talked to you about the Irish Pied or blanket pied. That's her. She has one copy of pied. She should not look pied at all. Maybe a little bit of white spotting. She is Irish Pied. She is also curly and full fluffy. So, black and tan, fluffy. Now, here's where we get interesting. We don't have a test for big rope. She is a big rope. Black and tan, fluffy, big rope. We're gonna say fluffy, curly, big rope. Just got C1, dominant, doesn't take 2. Black and tan, fluffy, curly, big rope. Carrying, Rojo, cocoa, blue, cream. Irish Pied. Oh, I should add this too. She also carries this. Remember I said there's only one thing that is not the A locus, but is represented by an A that is capital? That's pink. She also carries pink. So again, not visual pink, but she can make them. Lydia. Hey, girls, let her come here. Come here. Come here. You're not going to come here. Let me pick you up. Let me pick you up. All right. Here's Lydia. Maybe you guys have seen her on my page. So she's full fluffy. She's kind of dirty right now, but she's full fluffy. She's curly. She's big rope. As you can see, she has black and tan. Now this is the Irish Pied. She's got white feet, white face, white down her chest, white down her belly. The whole bottom of the dog is white. And another common thing is this patch on the back of the neck. So that's our Irish Pied, blanket pied, however you want to call it. Now this is very similar to the Panda Husky pattern. But one thing you'll notice, her tane points don't show on one leg, they show on this leg. Her pattern is less symmetrical. Her tan points come further down on this back foot than they do on this back foot. You won't see that usually in the pandas. They'll be very symmetrical patterning. Plus, look at the DNA. See if they're a pied carrier. No, Panda Huskies can carry pied. But then you can look at the parents. And if one of the parents is a husky, then there's probably a good chance you have a husky. Neither of her parents were husky. So we know she's an Irish Pied. All right, I'm gonna put her down. And I'm gonna go on to, let's see, we'll do Kona. Kona is AT, little b, little co, little d, em. She is ky. She is capital S. She is big M, little m. She is L1, L4. Okay, that is that for Kona. So if you want to pause here, take a second, try to figure out what she is, and then I'm going to go ahead and tell you. Okay, I hope that you paused and took the time to figure this out. Again, AT, pan plates. Now instead of like Lydia, where she was a carrier of all these colors, now we have 2 copies. Lowercase letter means they have it. She's not a carrier. She has 2 copies of every recessive color. So this is New Shade Isabella. Is she covered in cream? No. She has 2 copies of masked. So she is a masked New Shade Isabella. KY, no brindle. So she is not brindle and not trindle. Big S, no pied. Big M, little m. She is Merle. L1, L4. She is fluffy. And again, she's downstairs. You'd have to go look at like my Instagram if you want to see her. But this is what she is, a New Shade Isabella Merle Fluffy with mask. No pied, no brindle, no cream. All right, my last girl that's downstairs, Wednesday. I think she's AT as well, but to make it a little more interesting, I'm going to say she's ATA. She is big B, little b, big CO, big CO, big D, little d, E, little e, KY, KY, big S, little s, big M, big M. I think she's, I don't know, we'll say L1, L4. And then here's a fun one, she's got an F. Go ahead and pause. Try to figure out what Wednesday is. And I'm gonna come back and tell you in a second. Okay, I'm sorry if you can hear my dogs going nuts. They're ready to have playtime. So Wednesday, ATA, still tan points, carries solid. Solid is the most recessive. The tan points will overcome it. Because she's ATA, the tan points will be less defined. Rojo, carrier. Coco, she's big CO, big CO. No Coco. Big D, little d. Dilute or blue carrier. Big E, this is our maskless. Cream, most recessive, so carry. KY, KY, no brindle. She is not a brindle or a trindle. Big S, little s. She carries that pie. Big M, big M. She is not a Merle. L1, L4, 2 copies of Fluffy. She is Fluffy. Then we add this F. That is our furnish. So she is a flutal. Now, if she, Peanut, if she does not have 2 copies of any of these recessive colors, what did we say our base color is? So we know she carries, 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 carries. She only carries color. Does not have 2 copies of anything. She is black. That is our base color. ATA, Ian Tan. Flutal. Carrying. Rojo. Carrying blue. Carrying cream. Carrying pied. That is my girl Wednesday. You can see her on my page, but there you go. Don't let this get you. If they do not have 2 copies of a recessive color, if they are not fawn, or they do not have 2 copies of this, they are black. So, I hope you're getting a good idea of how to figure out what a dog is at this point. We'll try, I'm going to make up one so we can use some things that I don't have. So if we have an AYA, we'll say big B, little b, big CO, little d, EM, big E, KY, KB, we'll just say big S, big M, we'll say big L. Actually, let's do big L, little L. I'll just leave it at that for now. Try to figure out what this would be, because this is where things start to get interesting. Okay, I hope you paused, did your homework there. AYA. A is recessive to AY. AY is fawn. We have a fawn. Carries Rojo. Big CO. No Coco. Little d. 2 copies of blue makes blue. EM, mask. Big E, maskless. Do you remember this? Mask beats maskless. So this is a masked fawn. KYKB. Now we have that brindle. So what happens when you have brindle plus fawn? you have a brindle. No pied, no Merle, carries fluffy. So you're thinking, we have I don't know, blue fawn maybe. But that's not true because of this brindle. We will have a blue brindle, carrying Rojo, carrying fluffy. So we'll have a masked blue brindle. So this will look like a brindle dog, but instead of the normal brindle, it will be blue colored. Now, if I change this, and we keep everything else the same, but we change that AY to an AT, what do we have now? Nothing else changed. We still have brindle, but we don't have fawn, but we have tan points. Brindle plus tan points, trindle. So this is your genotype, but what you're going to see is a blue dog, a masked blue dog. So they'll look like River, where they're blue and they have the lighter mask caused by the dilution. And then they will have tan points, but the tan points will be brindled. You may barely be able to see them because they will have striping through them. That will be blue-black in color. This dog still carries Rojo. It does not have Coco. It still carries maskless. It still carries fluffy. But its entire phenotype, the entire way that it looks, has changed. So, that shows you how fawn, tan points, and brindle interact. Now if I take any of those and I make it littly, what happens? White paint, dog scream. Same thing. So any of these colors we talked about, any of these patterns we've talked about, any of that, you can add big rope to. You can add husky, the KIT gene, kit, to it. You can make a koi by putting Merle on top of that. So start with your colors, then go to your patterns, your pied, your Merle, your kit gene. Then go to your coat, your fluffy, your curl, your furnish. That will help you keep things separate so that you know what you are looking at when you're reading DNA. Now, I think that's a good start. I'm happy to make further videos pulling up DNA sheets or taking any that you want to send me and printing them out, writing them out, whatever, putting them up here for us to go over. But for the sake of this video, I'm going to stop at that. Let you practice, let you ask questions. I'm happy to answer anything I can. But the last thing that I wanted to go over, one thing that got me to actually do this, even though I've been thinking about it for a long time, was something to do with Merle. And this is called mosaic or mosaicism. Now remember, when we talked about Merle, what do we have? We have MC, MC plus, MA, MA plus, M, and MH. And this is our cryptic Merle, atypical Merle, standard Merle, and Harlequin or Tweed Merles. So where does that leave this? Well, this comes all the way back to genes, loci, phenotype versus genotype. So obviously, you know how puppies are created. So when the stud, we inseminate the female, we've got a sperm, we've got an egg. Now, if you remember, Peanut, hush. Our genes. Girl, wait. Look like this. Our DNA looks like this. It's our double helix. One side is from mom, one side is from dad. So dad is carrying one set of genes in his sperm. These are not full cells. They do not carry full DNA. They carry half. Mom's egg carrying half of a set of DNA. When these two come together, they put it together. And that's where those Punnett squares come in. So we could predict every locus for mom and dad and what they can give us. But when these combine, it does not always go to plan. We do not always get everything copied perfectly. And Merle is an example of that. It can change. So we talked about the length, shortest to longest of the Merle gene. So let's say that dad is a Harlequin Merle. Dad is MH, so he has the longest Merle gene possible. Now what can happen is every time his cells split to create sperm, this Merle gene might get broken. So he might pass Harlequin to his puppy. Lydia, stop. But if the Merle gene gets broken, so it was as long as it can be, but when we went to copy it, something happened, and all of a sudden it broke off there. Now it's shorter. Now it's a standard Merle. So the next sperm and egg that are going to meet, this one might just be a standard Merle. Now, let's say that when these two meet, they create your puppy, right? So now we have a cell that has a full set of DNA, but it's literally just a cell. So what happens? So what can happen is dad's already passed Merle genes, which could have been broken and may be different from the length that mom or dad already had. But this puppy, we're gonna say it got that copy of MH. Now, how's a cell become a puppy? It splits. So this cell becomes two cells. And when that happens, the DNA has to replicate. And when it replicates, when it copies itself, sometimes it does it wrong. And it is really, really common for Merle genes to copy themselves wrong. So maybe we have that MH in this cell, but a piece broke off and got lost, and now we have standard Merle here. Now, these cells keep duplicating. So if they keep doing it correctly, then the next one will be 4 cells. Each one turns into 2. Now we have MH, MH, standard Merle, standard Merle. And that can keep happening until you have an entire dog. Now, because of this, that means that your dog, depending where these cells land, what they turn into, these could turn into liver cells. These could turn into skin cells. They could turn into coat cells. So they may or may not affect the phenotype, how your dog looks. But their genotype could be a mix. And that's what the mosaic is. So where this matters is when you are breeding, you could have a Harlequin Merle in phenotype. But if these standard Merle cells went to the testes, these are where your sperm is getting created from. Your dog will now pass standard Merle, not Harlequin Merle. So when you did that cheek swab and you found out that you had a Harlequin Merle, you're wondering why none of his puppies are looking Harlequin. This is why. His coat got these Harlequin genes. His testes got Merle genes. And this can keep happening. If you actually do a cheek swab, a blood test, a hair test, and a semen test on a dog, and I keep saying the male because it's very hard to do this kind of test on the female because it would be in the eggs. There's no way to take those out and test them. So if you test sperm, blood, hair, cheek swab, you might get 4 different Merle numbers, depending how many times that gene got broken during replication. And so what got me was people were arguing that a dog can pass mosaic. It cannot. And the reason is that if this went the other way, we're going to use the same dog, but this time an MH and an M both went and got to the testes, and an MH and an M both went and got to the coat, and these just kept dividing to make your dog have a really odd Merle pattern. It's really cool. Why? Because some of it's Harlequin, some of it's Merle. Its skin cells and coat cells are all mixed together with different patterns. But the testes, depending which cell gets used to make the sperm, he can pass a Harlequin, he can pass a Merle, standard Merle. And again, while passing this, while replicating these to create sperm, it can get broken. So this M could become MC+, it could become MC, it could become MA. So we don't know why the Merle likes to break so much. All we know is it does. It's about 16 to 20%, I think, of dogs that are Merle, that have been studied, are mosaics. You test all their different cells that you can get to, and they will be different. This likes to break, but that sperm cannot contain multiple Merle genes. It gets one. So it will get whichever random chance. This could be one sperm cell, this will be another, this will be another. Now, does that mean that you won't get mosaic puppies? No, you totally could. There's a pretty high chance. And maybe there's a gene that we don't know about that makes it higher chance that your dog breaks their Merle gene upon replication. But they're not passing multiple types of Merle to a puppy. If you have a mosaic Merle, they are a genetic anomaly. They will not pass that genetic anomaly reliably. We do not know that a mosaic Merle will make mosaic Merles. They can make Merles, and those Merles can be different sign numbers than the parent. But mosaic itself does not pass. So I hope that made sense. If I need to explain that again, please let me know. I'd be happy to try to go over that more clearly. But I just wanted to put it at the end because it's probably one of the most confusing things and something that matters the least to the general breeder who may not even test their Merle's side length. Yeah, so I'm gonna cut this off here. I'm just gonna edit some of these pieces together real quick and throw this up on YouTube. Hopefully everything was in frame. Hopefully I don't sound too crazy doing this at the last minute, unplanned in the middle of the day, but I felt like this could really help a lot of people, and I will be happy to answer questions or make follow-ups to anything that we spoke about today.